Hello everybody. In this video we're going to integrate cosine 8 of x. For this integration we're going to be needing fourth expansion of binomials, so we can utilize Pascal triangle for that. And this is how we construct Pascal triangle. We write 1 1 1 and then we obtain the next line by adding the terms. So 1 plus 1 is 2 and edges are always 1. So 1 plus 2 is 3, 2 plus 1 is 3, and edges are always 1. 1 plus 3 is 4, 3 plus 3 is 6, and 3 plus 1 is 4. Edges are always 1. So what do these numbers mean? These numbers are the coefficients in the expansion. So in the a plus b to the fourth power term, our coefficients are 1, 4, 6, 4, and 1. Our a term will be starting from 4 and in the decreasing order 3, 2, 1, 0, and our b term starts from 0 through 4 in the increasing order. The next tool we're going to be needing will be half angle identity. Half angle identity for cosine is square root of 1 plus cosine of 2x over 2, and if you square on both sides you obtain cosine squared of x is equal to 1 plus cosine of 2x over 2. And you can pull out 1/2, so you obtain 1/2 times 1 plus cosine of 2x. So this is the nicest form of the half angle identity you can use. Whatever the angle here will be doubling here. So if you have here x, then you're going to obtain here 2x. If you have here 3x, then you're going to obtain here 6x. Similarly, half angle identity for sine squared of x will be 1/2 times 1 minus cosine of 2x. So the only difference between sine and cosine in the half angle identity is 1 plus cosine of 2x or 1 minus cosine of 2x. The next identity we will be needing will be Pythagorean identity. Sine squared of x plus cosine squared of x is equal to 1. From here you can pull cosine squared of x or sine squared of x and make it equal to either 1 minus sine squared of x or 1 minus cosine squared of x, depending on which one you need. If you have even power, using half angle identity is good. If you have odd power, then break it into even plus odd power and use the Pythagorean identity. We will see the application here in cosine 8 of x as well. We also need to know how to integrate cosine and sine in a practical way. If you have cosine ax dx, then the integral will be 1 over a times sine ax plus c. If you have sine ax dx, then integral will be negative 1 over a times cosine ax plus c. If you can't remember these, then you can visually learn that. Integral of the trigonometric functions in the counterclockwise. Construct unit circle, make up positive sign, positive cosine and negative cosine directions. If you go to anti-clockwise, you obtain the antiderivative. If you go to clockwise, you obtain the derivatives of the trigonometric functions. Let's begin. Our first step for cosine 8 of x is to break cosine into cosine squared of x to the fourth power dx. Now we're going to use the half angle identity and express cosine squared of x as 1/2 times 1 plus cosine of 2x. So we have 1/2 times 1 plus cosine of 2x instead of cosine squared of x here. And we have the fourth power here. This is the x. Now we're going to expand this to the fourth power. First we can expand 1/2 to the fourth power and pull it in front of the integral sign. It's going to be 1 over 16th. And inside we have 1 plus cosine of 2x to the fourth power dx. In the Pascal triangle expansion here, this is our a term, this is our b term. So this is the binomial two terms, a plus b to the fourth power. So our coefficients are 1, 4, 6, 4, and 1. Our a term is 1, and our b term is cosine of 2x. So let's copy paste everything. So we have 1 times cosine of 2x, 1 times cosine of 2x, and 1 times cosine of 2x. Our a term starts from the fourth power through the 0th power. And our b term starts from 0th power, 1st power, 2nd power, 3rd power, and the 4th power. Now we're going to clean this up and rewrite the integral. We have 1 over 16 in front of the integral sign. From the first term here, we obtain just 1. From the second term here, we obtain just 4 times cosine of 2x. Here we obtain 6 times cosine squared of 2x. Here we obtain 4 times cosine cube of 2x. And finally we obtain just cosine fourth of 2x. And this is our integral here, and this is our dx here. Now let's name the blocks. Let's call this block A, block B, block C, block D, and block E, and separate the integrals. So we have 1 over 16 in front of the integral sign, and we are separating the integrals. Our block A is integral of 1 dx. Our integral B is 4 times integral of cosine of 2x. And we can pull 6 in front of integral sign. We have cosine squared of 2x here. We have 4 integral of cosine cubed of 2x. And finally we have integral of cosine fourth of 2x dx. Now we can integrate each blocks separately. Our integral A is the integration of 1 with respect to x. Antiderivative of 1 with respect to x is just x. So we're done with the integral A. Let's continue with block B. Our block B is 4 times cosine of 2x. We know that integration of cosine is 1 over a sine of ax plus c. In our case, 1/2 sine of 2x plus c. So 4 divided by 2 is 2. 2 sine of 2x plus c is block B. That is completely done. Let's continue with our block C. Our block C is the integration of 6 times cosine squared of 2x dx. Whenever we have even power, we apply half angle identity. So here we are going to apply integral 1/2 times 1 plus cosine of 4x, because we are doubling this angle in the half angle identity, and dx. We can pull 1/2 in front of the integral sign. 6 times 1/2 is 3, and we have integral of 1 plus cosine of 4x. If we call this C1 and if we call this C2, then our C1 will be integral of 1 with respect to x is just x, and antiderivative of cosine is 1 over a times sine of ax. And if you distribute 3 inside of the integral sign, then you obtain 3x plus 3/4 sine of 4x plus c. So our block C is totally done. Now let's continue with block D. Our block D is 4 times cosine cube of 2x integrated. So 4 integral cosine cube of 2x dx. This is our block D. Here we're going to break cosine into even and odd power at the same time and apply the Pythagorean identity for the even power. Cosine squared of 2x is 1 minus sine squared of 2x according to Pythagorean identity. Let's revisit Pythagorean identity. Sine squared of x plus cosine squared of x is equal to 1, and if you solve for cosine here, you obtain 1 minus sine squared of x. So our integral turns into 4 times 1 minus sine squared of 2x times cosine of 2x. Here we are going to apply u substitution. Let u be equal to sine of 2x. Then du will be the derivative of this. Derivative of sine is cosine. And we're going to apply the chain rule, multiply it by the inside function's derivative. So derivative of sine of 2x is 2 cosine of 2x dx. And if you solve for dx here, dx will be equal to du over 2 cosine of 2x. Let's rewrite everything in terms of u. We have 4 1 minus u squared, and we have cosine of 2x here. Instead of the x, we have du over 2 times cosine of 2x. Cosine of 2x cancels. If we pull 1/2 here in front of the integral sign, 4 times 1/2 is 2, and we have 1 minus u squared du. Now we know how to integrate this. Antiderivative of 1 with respect to u is just u, and here we apply the power rule. We add 1 and divide it by the power. And we can distribute 2 inside, so 2u minus 2/3 u cubed plus c. And if we bring u back, we have 2 sine of 2x minus 2/3 sine cube of 2x. So our block D is totally done as well. This is our block D. Let's finally integrate block E. Our block E is cosine 4 of 2x. Here we are going to break cosine into cosine squared of 2x to the second power. And we're going to apply half angle identity to inside. So inside we have 1/2 times 1 plus cosine of 4x to the second power. Now we're going to distribute the second power inside. So 1/2 to the second power is 1/4. 1 plus cosine of 4x to the second power dx. Now we're going to expand this to the second power. A plus b, the quantity squared, is equal to a squared plus 2 times ab plus b squared. Or you can use the Pascal triangle, but this formula is more practical. So here our a term is 1 and our b term is cosine of 4x. So we have 1/4 in front of the integral sign. So integral of a term is 1, so 1 squared is 1. 2 times a times b is 2 cosine of 4x. And b squared term is cosine squared of 4x. Now if you call this block E1, this is E2, and this is E3. Now we can do it one by one. Our E1 term will be integral of 1. Integral of 1 is x. And our E2 term will be 2 integral of cosine of 4x. So antiderivative of cosine is 1 over a times sine ax. So 1/4 sine of 4x plus c. So this is going to be 1/2 sine of 4x. our e2 term is also done. Our e3 term is integral of cosine squared of 4x. Here we're going to apply the half angle identity. So it's going to be 1/2 times 1 plus cosine of 8x. So we're doubling this angle, the x. We can pull 1/2 in front of the integral sign. And we have integral of 1 plus cosine of 8x dx. Now we know how to integrate this. 1/2 times integral of 1 with respect to x is x, and integral of cosine of 8x is 1/8 sine of 8x plus c. And if we distribute 1/2 inside, and if we distribute 1/2 inside of the parentheses, we obtain 1/2 x plus 1/16 sine of 8x plus c. So this is our block E3. Now our block E1, E2 and E3 will be multiplied by 1/4 in front of the big integral sign. So we have 1/4 times, let's go check E1. Our E1 is just x. Our E2 is 1/2 sine of 4x. And our E3 is 1/2 x plus 1/16 sine of 8x. We don't need c here, we can write c in the end for the big integral. And if we distribute 1/4 in the parentheses, we're going to obtain this. Before that, we can merge these like terms. X and 1/2 x makes 3/2x. So 1/4 times 3/2x is 3/8x plus 1/4 times 1/2 is 1/8 sine of 4x plus 1/4 times 1/16 is 1/64 sine of 8x. And this is done for block E totally. So this is our block E. Now our big integral was 1/16 times block A, block B, C, D, and E. What we obtained from integral A is just x. Integral B, C, D, E is listed here. Now we're going to multiply those blocks with 1/16. Before we distribute 1/16 inside, we can combine the like terms. We have x, 3x, and 3/8x. Altogether we make 35/8x. Our another like terms are sine of 4x. Another like terms are sine of 2x. You can either combine before you distribute, or you can distribute and then combine. So I would like to combine before I distribute. So we obtain 35/8x from the x terms. Here we have 2 sine of 2x and 2 sine of 2x. Together makes 4 sine of 2x. We have 3/4 sine of 4x and 1/8. So 3/4 plus 1/8 is 7/8. And the rest is by itself. Now we can distribute 1/16 inside. So 1/16 times 35/8 is 35 over 128x. 1 over 16th times 4 will be 1/4. 1 over 16th times 7 over 8 will be 7 over 128 sine of 4x. And 1 over 16 times 2/3 will be 1 over 24 sine cube of 2x. And finally 1/16 times 1 over 64 is 1 over 1024 sine of 8x plus c. So this is our final answer. So once you label them correctly and follow the guidelines and track the numbers correctly and using the correct tools, you can integrate cosine 8 of x. Thank you for watching.